This is lesson 7, where we're going to talk about decision trees as the last component of our section on decision analysis, the last of the 3 lessons on decision analysis. So let's take a look, and again, we'll refocus on that problem, same problem that we've been looking at. And you'll remember from the last class, we were given information about the future states of nature, good, fair, or poor economic conditions, and we were able to determine expected values for each one of the respective decisions. And so for the apartment, our decision, or the expected value was 28,000. For the office, it was 29,500, and of course for the warehouse it was 500. So the maximum of the best decision that we could make at that point was to invest in the office, and it would return $29,500 on average. Now there's another way that we can represent this decision, and it's called with a decision tree. You know, we had already talked about in a previous lesson probability trees, where we're going to add one component to the probability tree to convert it to a decision tree. And what we're going to do, instead of having just random events as we had on the probability tree, we're going to add this symbol that's the square. And these symbols are actually quite important to help describe what the process is. But the square is going to represent a decision or a choice, something that we can actually choose. And we're going to use the circles or a node to represent our random event. And so this same problem that we've been looking at for several lessons now can be represented with a decision tree. And there's 3 steps to this decision tree. And the first step is that we're going to build this tree from left to right along a normal sequence of time. And so our decision, as we've faced already, there's 3 choices. Each one of those choices is represented by a branch of this tree. We could choose the apartment, we could choose to invest in the office, or we could choose to invest in the warehouse. And that's our decision. So you almost want to consider this problem is that you're a person here, and forgive my stick figure, but you're a person standing here at this point, at point 1, trying to decide which one of these options to choose. And so then once you make this decision, the next thing that occurs is going to be in a random. We're going to place those random events at the end of each one of these branches. And that random event is where we will wait to determine what the future state of the economy is. Either it's going to be good, it's going to be fair, or it's going to be poor. And that's going to be the same for each one of these choices, because if we invest in the office, the outcome of the future is going to be good, fair, or poor. And then the same thing for the warehouse. So then that's going to look like this. And then once we assign these random events and their resulting outcomes, we will assign then, of course, probabilities with each one of those. And then finally, we'll assign the leaves of those branches. And at each end of the branch, there's going to be a leaf, if you will, or the resultant outcome of that particular sequence of decisions and then future states of nature. And so this then completes the building of this tree. The next step in our process is to calculate. We want to calculate backwards from right to left, not through the tree. We want to calculate our expected values, and then we do that just as we've done for our problem. So with the expected value for this random event is 28,500, because we're going to add excuse me, we're not add, we're going to multiply 0.2 times 50,000 plus 0.7 times 5,000, and then plus 0.1 times 10,000. So we do this calculation to result in our expected values. And of course, we'll do that. We've already done this calculation several times now, and we know what the result is. And now that we know the result, we can come back to this point in our process where we are here is our decision maker standing at the beginning of our process, and we want to make that decision about which way to go or which option to choose. And then that begins the next step of our process, our third step, which we will decide. We're going to make a decision back through this decision tree which choice we will make. And in this case, of course, we'll choose the office, to invest in the office. We won't invest in the apartment, and we won't invest in the warehouse. So this means that double hash means we're not going to choose that. The arrow means we will choose that option. Last point I want to make, and again a point of emphasis, is the following. And we also know that the expected value now for our decision is $29,500 if we invest in the office. But again, the main point that I want to make is the following. If you invest in the office and you wait to see what the economy is going to be, which either will be good, fair, or poor with those probabilities, your result will either be your return 100,000, 20,000, or you could lose, small chance, but you could lose $50,000. So the key thing is expected value represents an average. This is the return that you would receive on average over the long run if you had several opportunities to invest in this or similar decisions. Because if there's only one time option of investing, you're either going to return 100,000 or 20,000, or you're going to lose 50,000. And so in that case, if you're only facing this type of decision once, you may want to choose some other solution. And probably that would be to invest in the apartment, because as you can see, if you invest in the apartment, you'll never have a negative return. So you will always have a positive return, even though you won't have the opportunity to get a very large return. You'll never have a loss, which with these other alternatives, you could in fact have a loss. You've seen the different perspectives, optimistic, pessimistic, and so forth, that allows you to analyze those things. So these decisions are taken from a long view approach, or the approach where you have the option of facing many similar types of investments, such as in the stock market or real estate, if you're making these investments over and over again. All right, so let's look at a new problem. And this problem is out of the textbook, and it's the Southern Textile Company example on pages 39 to 41, so you could follow this along in the textbook and read about it. And again, we're going to build this decision tree as a sequence of decisions, and sometime you'll see this process written as the sequential decision tree, because it allows you to analyze multiple decisions that come back to back over in time. So let's look at this problem. All right, the first thing is we have a decision, and again, we're building from left to right in time. And the decision is either to expand our property and pay $800,000, or to purchase land and pay $200,000 for the land. Then at the next step, we have a random outcome, and again, that's a random event that's represented with a circle. And of course, any time you have a circle or a random event, you're going to have probabilities associated with those, and so you'll assign your probabilities. And in either case, you're going to have, if you expand your land, your property, there's a 60% chance that the market will grow. There's a 40% that the market won't grow. If the market grows, you'll return $2 million. If the market doesn't grow, you'll earn only $225,000. In this case, if you purchase land, the market could grow at the same rate, 60% or 40%. And then it turns out we're going to face another decision at that point. And so there's going to be a decision that we're going to face at the end of this growth period. So let's look at that on the next slide. So for the case of if you purchase land and the market grows, then we'll have another choice where we could either expand the land again at $800,000 for a cost of $800,000, or at that point we could sell the land and earn a net profit of $450,000. In the other case, if it happens out of our control that the market doesn't grow, we'll still have a choice, but then we could build a warehouse on the property at a cost of $600,000, or sell the land for less than what it if the market grows. If it doesn't grow, we could sell it for $210,000. And then again, now we're going to face another set of random events. Again, there's going to be another sequence of either market growth or no growth. So if the land is expanded, and notice here the probabilities change, because if the market has grown once, it's more likely that it will grow again. And in this case, if you choose to expand, market grows, you'll return $3 million. If the market doesn't grow, you'll return $700,000. And down on the no market growth branch, if it doesn't grow in the first phase, you invest in the warehouse and it grows in the second phase, you'll return $2.3 million. But again, that's a very small chance, less than 50% chance that the market will grow. But if the market doesn't grow, you'll still return $1 million in this case. So then the question is, this completes the building of our tree. And at the end of this tree, again, you'll notice there's a return. Sometimes, in this case, the returns are positive. Sometimes they're negative. But in every case that there's a random event, there's probabilities associated with that event, because we don't know the outcome. And again, every time that we have a decision, we get to choose which branch we're going to take. So now the next phase is to calculate. And we're going to calculate from right to left in our decision tree. Whenever we face the calculation at the random event, we calculate the expected value. And every time we are at a decision node, we get to choose the most favorable option. These are two critical ideas and then very important steps. So let's look at this process. So here's our completed decision tree. And what we're going to do for node 7 here, we're going to calculate an expected value for this location, EV at 7. And we're also going to calculate the expected value for location 6. And we can do this just in isolation. We don't have to consider anything else on the decision tree at this point. And that's on the next slide. We're going to grade this out. We're only going to be considering these two, if you will, sequence of this random event that's coming up at locations 6 and 7. So again, we're going to calculate that expected value, and hopefully you're ahead of me now, because the expected value at 6, let me start over. In fact, let me type this. The expected value at 6. Of course, we're going to do the multiplication. It's going to be 0.8 times 3 million plus 0.2 times 700,000. And that turns out to be when you do the arithmetic, 1.39 million. And then for the expected value at location 7, we're going to do a similar calculation, of course, using the information that's there, 0.3 times 2.3 million. And we're going to add that to $1 million. I've got one too many parentheses in there. And that turns out to be equal to, I've got this is 1.3. And in this case, let me that's not correct. Hopefully you've caught this. This value is in fact $2,540,000. Okay, and that's EV for 6, the expected value, location 6. As I've been trying to type that in there, hopefully you've been calculating that and have verified that that's the case. Now, the other thing that's important is that once we do this, we can essentially ignore this part of the tree, because in a sense, we've resolved these by calculating that expected value. And so now we're ready to go to the next part of our decision tree, which is our decisions. And now we have the luxury of being able to choose. And again, we've brought those expected values forward. This is the expected value at 6. And this is the expected value at 7. And so now we have the opportunity to choose between these two choices. In location 4, we can choose between expanding or selling. and hopefully you're ahead of me, and you can see that the choice for expanding, the expected value is 2.54 million minus our 800,000. And of course, that's going to be equal to, in this case, the expected value. This is going to be equal to 1.74 million, 1,740,000. And in this case, and so when we make our choice here at location 4, we are actually choosing between 1.74 million and 450,000. And of course, in this case, we'll definitely choose the 1.74 million. And so the expected value for location 4 is that 1.74 million. And we'll repeat that same process to compute the expected value for our location 5. And of course, we're going to choose between 1.39 million minus 600,000. And of course, that's going to be equal to, hopefully you've already done the arithmetic. That's going to be 790,000. And so then our choice is between 790,000 or 210,000. And of course, just like above, in this case, we would choose 790,000, which becomes our expected value at location 5. And then again, you can ignore, now that we've done this, we can ignore this part of the tree and only consider the next part of the tree. So we've made our decisions. The expected value is 1.74 million in this case. It's 790,000 in this case. And the next step that we face moving to the left is we're going to reach a random event. And so we're going to calculate the expected value. And hopefully you've got the rhythm of this thing. So now of this process, the expected value at location 3 is in fact 0.6 times 1.74 plus 0.4 times 790,000. And doing that arithmetic, that comes out to be 1,360,000. So 1,360,000, and that is the expected value at location 3. So expected value at location 3 is 1,360,000. Well, we're at a similar point now. We calculate the expected value for location 2, and again, this is getting. Hopefully, you'll get the feel for this. The expected value at location 2 is going to be 0.6 times 2 million plus times 0.4 times 225,000, which is the return if there's no market growth. And that expected value turns out to be 1,290,000. That went off the page. 1,290,000. So now we've resolved these, and now we can go. We're back to our original decision point where we're choosing between these two options. We can pay we can pay 800,000 and receive on average 1.29 million, or we can pay 200,000 and on average receive 1.36 million. And so in this case, this expected value is minus 200,000. In other words, it costs 200,000 firm to get this expected return. And so our expected return in this case is 1,160,000. And in this case, our expected return is 490,000. And now we're left at our original decision point, and here's our decision maker again at our original decision point. And now we need to know which one we're going to choose. Do we choose this expected value or this expected value? And clearly 1.16 million is more than 490,000, so we're going to choose to purchase the land and have an expected return of 1.16 million. And so now we've completed our calculations. We just need to determine what are we going to do. And so this decision tree shows all the expected values at every point, and we're going to begin at the first decision, and we're going to walk through this decision tree. And what we'll do is we'll just follow through. At this location, we're going to purchase the land, and the overall decision is worth 1.16 million, but we're going to purchase the land for 200,000, and then we're going to wait to see what happens with the market. If the market grows, and let me start over. If we have our decision maker here, and we are going to choose to purchase the land, we're not going to choose to expand. When we get here, we have to wait and see, is the market going to grow? And I'm going to try to do this with a dotted line. If the market grows, because we don't know, and we reach this decision point, we're going to choose to expand the land and not sell it, because our expected value is larger. And then once we get once we make that decision, then we're going to wait to see whether or not there's market growth or there's no market growth, and see what our ultimate return is. Either 3 million, which is a high probability that that's what will happen, or 700,000 return. On the other hand, if the market doesn't grow, once we get here, we will decide then to develop the warehouse. We will not sell the land, and then we'll wait to see whether the market grows or doesn't grow, and we'll receive a return of 2.3 million or 1 million. And so again, this is a process. Again, I want you to make sure that you realize that given this decision sequence, we will realize one of these four outcomes: 3 million, 700,000, 2.3 million, or 1 million. We'll not ever receive 1.16 million. But if we have this type of decision that we're facing over and over again, then on average, the 1.16 million is our net return, including all of our expenses. So that's how this process works. There's only one step left, and that's to write a report and give the summary to your decision maker. Again, this is just a representation of what decision that we're making, just as I drew on the last chart. And here's the summary report that you should give. The expected net profit is for this decision sequence is 1.16 million. Southern Textile should purchase the land for its new plant, and then if the market grows, it should expand the plant. Or if the market doesn't grow, Southern Textile should construct a warehouse on the land. So this is the process for the decision trees. I suggest you try it. We're going to, in the next shorter lesson, we're going to look at a quick example.